Welcome, deep divers. Ever feel like, you're just drowning in information, constantly trying to figure out what's actually true, what you can rely on?
And how we even know anything in the first place.
Exactly. Well, today we're diving deep into source material that really tackles that fundamental question head on. Think of it as a foundational guide.
Right. To the mechanics of proof, knowledge, and figuring out the world around us.
Our mission in this deep dive is to act as your guides through your source material, extracting the most potent insights
That's a surprising fact.
and those valuable aha moments. We want to give you a shortcut, really, to grasping the engine room of being well-informed.
Let's do it.
Yeah.
So where do we start? Logic itself.
Yeah, let's start unpacking what this material tells us about the very nature of logic.
Okay. Well, the source defines logic in a very powerful way. Not just, rules for arguing,
Right.
but as the science of how the human mind operates specifically in its pursuit of truth.
Okay, that frames it differently. It's less about winning debates and more about building reliable knowledge. The source even goes so far as to call it the science of proof or evidence.
Exactly. Its main role, according to the source, is to give us a test, a way to check if a belief is genuinely well-grounded.
Especially when that belief claims to be based on evidence, right?
Precisely. It's not really concerned with beliefs that just arise from, say, internal feeling without any external support.
So logic is the tool for verifying if our conclusions actually stand up to scrutiny based on the information we have.
Yes, and the source really stresses the importance of this. It argues that progress, especially in complex areas, absolutely requires advances in our understanding of logic.
Because if our basic logical principles are fuzzy or insufficient,
We just end up stuck. Endless disputes, going nowhere. Things stay defective, as the source puts it.
what I find fascinating here is how broad the source's view of logic is. You said it's instrumental for evaluating evidence.
Determining if we have enough evidence, even organizing facts for investigation.
Yeah.
It covers formal reasoning, sure, but also these really foundational mental operations, like naming, classifying things.
Defining concepts.
Right, defining concepts, all serving the central goal of finding truth.
Okay, speaking of defining concepts, the source tells us that anything we believe or disbelieve when we put it into words has to take the form of a proposition.
Or an assertion, yeah.
This is where truth and error actually reside in these statements.
Right, a proposition is a statement that affirms or denies something about something else. You need at least two distinct ideas involved.
So just saying the tree, that's not a proposition.
Nope. Nothing to believe or disbelieve there yet, but saying the tree is tall, that's a proposition you can assess for truth.
Okay. Which brings us to how we label those ideas, names. The
Yeah.
source spends significant time on how names function.
Making a key distinction between what a name denotes the actual objects it refers to.
Like Earth denoting our planet.
Exactly. And what it connotes the attributes or qualities it signifies.
So planet would connote things like orbiting a star, being roughly spherical.
You got it. And proper names, like Peter or London, they just denote specific individuals or places without really describing them intrinsically.
But for most names, especially general ones, their real meaning lies in that connotation.
Absolutely. When we say something is white, the name white connotes the attribute of whiteness, and we apply that name to objects because they possess that attribute.
And a name like man, it's not just a label for a group.
Not according to this source, no. It signifies a whole bundle of attributes: corporeity, organization, life, rationality, and so on.
Okay, here's where it gets really interesting for understanding how we use language and, well, think clearly. The source points out that the connotation of names can be a bit uncertain.
Yeah, or fluid. Especially in fields like, say, natural history, where things are grouped based on overall resemblance, not always a rigid checklist of attributes.
And this uncertainty can lead to sloppy thinking, right?
Definitely. The source warns about this. People sometimes use names based on just a superficial resemblance, allowing the name to kind of creep onto things.
That actually share very few or maybe even none of the original defining attribute.
Precisely. And this can happen even in, seemingly serious scientific writing sometimes.
Wow. So pausing to understand exactly what attributes a name signifies, its connotation, is absolutely critical.
Crucial for clear communication and avoiding massive confusion. The source suggests that defining a name is essentially about fixing its connotation, nailing down what attributes it represents.
And even though definitions are technically of names, doing it well forces us to look closely at the things the name denotes.
Right. Often by comparing them to find those common essential attributes.
Okay, so we have propositions stating things about named concepts. What is a proposition really asserting when it links a name to a subject?
Good question. The source argues that when the predicate is a concrete name, like in Snow is White, what we're fundamentally asserting is one of 5 relationships.
Okay, what are they?
Existence, coexistence, causation, sequence, or resemblance.
So the simple statement, snow is white, isn't just putting 2 labels together.
Nope.
It's asserting the coexistence of the substance snow and the attribute whiteness in the same thing.
Exactly. And the source contrasts this with older ideas, like Hobbes, which treated predication more like sorting or classification.
Just assigning labels, or saying one name includes the meaning of another.
Kind of. The critique here is that this misses the assertion of an actual matter of fact about how things are in the world, based on nature's laws, not just our filing system.
So any proposition that gives us real information is telling us something has an attribute, or that 2 attributes occur together or one follows the other.
That's the core idea, yeah. It's about reality, not just language games.
Okay. So how do we take these building blocks, names, and propositions, and use them to figure out something new or apply general knowledge?
Through reasoning or inference. And the source draws a really crucial line between 2 main types, ratiocination and induction.
Ratiocination, that sounds formal.
It is often associated with the syllogism. It's the process of inferring conclusions that are no more general than the starting points, the premises.
So reasoning down from general rules to specific cases, like the classic syllogism.
Exactly. All men are mortal. Socrates is a man, therefore Socrates is mortal. The source notes Euclid's geometry can be cast in syllogisms too.
But here's a critical insight you mentioned from the source.
Yeah, this is key. While the syllogism is a valid structure for proving a point if your premises are true, it's not how we discover genuinely new knowledge.
It's more like interpreting or applying a formula you already have.
Pretty much. The real groundwork, the actual source of the general rule, often comes from specific observations, even if we've forgotten them. The underlying principle the syllogism relies on is actually the inference from observed particulars to general rules.
So the syllogism is like a check, a consistency test.
That's a good way to put it. It checks if your application of a general rule to a specific case is logically sound, given that you accept the rule. It ensures consistency.
But the true engine of discovery, the leap from what we know to something unknown that's more general than our starting points, that's induction.
That's induction, according to the source.
Mm-hmm.
This is the process of taking particular facts we've observed and using them to arrive at general truths or laws.
This distinction feels fundamental.
It really is. The source argues that even the principle, often cited as the basis of the syllogism, the dictum de omni et nullo, what's true of a class is true of everything in that class.
Yeah.
Isn't a principle for finding new truths, but rather an interpretation or restatement of a generalization we've already made through induction.
So induction comes first, conceptually.
In terms of generating the general knowledge, yes. And in this light, names aren't just labels. They are powerful tools for remembering and communicating those inductive generalizations.
Like an artificial memory.
Sort of, yeah. They help strengthen our thought by letting us handle these complex generalizations.
Okay, so if induction is how we build these general truths, how do we ensure those inductions are reliable? How do we do it well?
Right. The source delves into the regularities we observe in nature, focusing particularly on patterns of succession, what we usually call causation.
Cause and effect.
Exactly.
Yeah.
And also patterns of things occurring together, coexistence. But the patterns of succession, the causal links, are seen as the most valuable.
Why? Because they let us predict.
And predict future events, yeah, and understand how to influence things. If A causes B, we can anticipate B if we see A, or try to produce B by creating A.
Makes sense. And the source heavily emphasizes the law of universal causation.
Very heavily. The idea that everything that begins to exist has a cause. And that cause isn't just one thing, it's the complete set of conditions.
The whole package.
The whole package, yeah.
Yeah.
The assemblage of conditions that, when present, mean the phenomenon invariably happens.
And cause and effect aren't always like one thing happening then the next.
Not necessarily successive in time, no. But the beginning of something new implies a preceding cause.
Yeah.
That full set of conditions.
And it points out that what we usually call the cause
is often just the final piece that clicked into place, the one condition that came last. But scientifically, the cause is that entire collection.
Okay. So how do we systematically figure out these causal links from observations? The source outlines several methods.
Yes. These are really powerful tools for investigation. First, there's the method of agreement.
Agreement. How does that work?
You look at different situations where the phenomenon you're interested in occurs. If all those situations have only one other circumstance in common, that shared circumstance is likely the cause or effect.
Can you give an example?
The source uses the example of dew forming on various surfaces. If you observe dew on grass, on metal, on wood, and the only thing all those situations have in common is that the surfaces were radiating heat rapidly, then that radiation is likely connected to the dew formation.
Okay, got it. What's next?
Then there's the method of difference. This is often seen as the most powerful, especially in experiments.
How's it different?
You compare two situations that are identical in every single way except one. In one situation, the phenomenon occurs. In the other, it doesn't. That single difference between them is pinpointed as the cause, or a necessary part of the cause, or the effect.
Ah, like a controlled experiment.
Exactly. The source mentions Dr. Brown-Séquard's experiments showing that cutting specific nerves stopped muscle function. The only difference was a cut nerve, and the effect was paralysis. Very direct.
Okay, what else?
There's also the method of residues. This is useful in complex situations where you already know some causes and effects.
How does that work?
You basically subtract the known effects of the known causes. Whatever is left over the residual phenomenon must be the effect of the remaining, maybe unknown causes.
Like process of elimination?
Kind of, yeah. The source gives an analogy. If you calculate all the known forces slowing down an object, friction, air resistance, and it still slows down more than expected, that remaining slowdown must be due to some other unknown resistance.
Clever. And the last one.
The method of concomitant variations. This is useful when you can't completely eliminate factors, but you can observe things changing together.
So if two things increase or decrease in sync.
Precisely. If two phenomena seem to vary in parallel, one goes up, the other goes up, one goes down, the other goes down, even if they're always present to some degree, they're likely connected causally.
Right.
The source mentions how the buildup of static electricity seems to vary directly with the intensity of the opposite electrical charge it induces nearby. They change together.
Okay, these methods seem incredibly useful for digging into causes.
They provide a systematic way to move from just observing correlations to inferring probable causal laws. But, as you'd expect, the real world adds complications.
Right. The source mentions complexities like composition of causes.
Ah, yes.
Yeah.
That's basically the standard situation where multiple causes are operating at the same time, and the total effect is simply the sum of their separate effects.
Like forces adding up. If I push a box and you push a box, the total movement is the sum of our pushes.
Exactly. Or think about forces in equilibrium in physics. It's additive. The source also mentions chemical reactions, like hydrogen and oxygen forming water, viewing the elements as agents combining to produce a new substance with properties derived from the combination.
And what about intermixture of effects? That sounds different.
That's when causes seem to modify each other's operation, so the combined effect looks qualitatively different. Heterogeneous, the source says, from just adding up the individual effects. Think maybe certain drug interactions where the result isn't just additive.
But the source clarifies this.
Yeah, it clarifies that even in these seemingly complex cases, if you trace it down to the most fundamental properties and laws of the components involved, the collective effect is still ultimately the exact result, the sum, in a deeper sense of those underlying interactions according to basic laws. It just might look very different on the surface.
So using these inductive methods, we arrive at general laws. The source makes a distinction here too, right? Between ultimate laws and derivative laws.
Yes. Ultimate laws are the most fundamental ones we know. They can't currently be broken down further or deduced from anything simpler. Derivative laws, on the other hand, can be explained by combining or applying more general, often ultimate laws.
And science progresses by doing this, by explaining complex laws as results of simpler ones.
That's a major way it progresses, yes. Explaining complex phenomena by showing they necessarily result from simpler, more general laws is a key part of scientific explanation.
The source mentions astronomy and optics.
Right, explaining things that propagate through space. A classic example is showing how Kepler's laws describing planetary motion, which were initially derived empirically from observation, could be explained deductively once Newton established the more fundamental ultimate laws of universal gravitation and motion. Kepler's laws became derivative laws.
But what if we haven't yet found those underlying more general laws? We can't always deduce things.
True. And that's where the source introduces the idea of using hypotheses. We can propose or imagine hypothetical laws or causes that might explain the phenomena we observe, even if we can't prove them directly yet.
So we make an educated guess.
Essentially, yeah.
Yeah.
An hypothesis could propose a real, but currently unproven cause acting according to known laws. Like Newton's initial guess that the gravity holding the moon in orbit was the same force as gravity on Earth, that was a hypothesis until verified by calculation.
Okay. What other kinds of hypotheses are there?
Well, the source also discusses hypotheses proposing a fictitious cause that operates according to known laws, maybe like early models of light waves using a hypothetical medium. Or, more speculatively, a fictitious cause operating according to fictitious laws.
But the source is cautious about these.
Very cautious. For a hypothesis about causation to carry real weight, it argues, the proposed cause should ideally be a vera causa, a real phenomenon that we already know exists and is capable, in principle, of producing the kind of effect we're trying to explain.
So just showing that your hypothesis could explain the facts isn't enough.
Not really strong evidence on its own, no. Not unless that hypothetical cause has some independent support or evidence suggesting it's real. Otherwise, it's just a potential story.
So the full scientific process often involves this interplay.
Right. A blend. Induction, to find potential laws of causes from observation. Ratiocination, or deduction, to calculate the combined effects of those laws in specific situations. And then crucial verification checking, if those calculated effects actually match the real-world phenomena.
Okay, so induction is key to discovering these general laws. But the source brings up another category, empirical laws. How are they different?
Empirical laws are uniformities, patterns that we've learned purely from observation and experience. We see that B consistently follows A, but we haven't yet figured out the deeper causal laws that make B follow A.
They're often discovered just by noticing patterns, like with the method of agreement.
Often, yes. You see a pattern holds across many cases, so you state it as a law, but you don't necessarily know the underlying mechanism.
And why is relying solely on empirical laws considered risky by the source?
The big problem is uncertainty about their scope. Because we don't know why they hold true, we can't be certain they'll apply beyond the specific circumstances, the range of time and place, where we've actually observed them.
They might just be temporary or local.
Exactly. They might be the result of a particular setup, a specific collocation of causes, as the source puts it, that might not exist elsewhere or at other times.
The source gives that day and night example again.
Yeah. Day invariably follows night, and night follows day. That's a perfect empirical law based on observation. But day doesn't cause night, nor vice versa. They're both effects of a common cause, the Earth's rotation relative to the sun. If, hypothetically, daylight were caused by something else entirely, it might not be followed by night. So the empirical law depends on the underlying causal structure remaining the same.
This really raises a fundamental question about certainty itself. How sure can we ever really be of any induction, any generalization from experience?
That's a deep question the source grapples with. It suggests that induction itself, at its most basic level, the assumption that the future will resemble the past in some ways, can't be strictly proven by pure logic, a priori alone.
So we have to assume it works to some extent.
Ultimately, yes. We rely on an assumption that some inductive patterns we observe must be reliable for us to even begin reasoning about the world from experience. It's foundational.
But are all inductions equally uncertain?
No, definitely not. The source argues there are certain types of inductions that approach absolute certainty. Think about the fundamental laws of space and number, or the very bedrock laws of causation itself, like every event has a cause. These seem universally true across all our experience.
So if a specific induction can be linked to these really certain laws.
Right. If we can show that a particular induction must be true, or else it would contradict one of these foundational, highly certain laws, then that specific induction gains a very high degree of certainty itself, beyond just being an empirical observation.
The source also critiques an idea about using inconceivability as a test of truth, something associated with Herbert Spencer.
Yes, it pushes back against the notion that if we simply cannot imagine the opposite of something being true, that proves it is true. The source argues that what we find conceivable or inconceivable is often just a product of our limited experience, our habits of thought, or even accidents of how we learn things.
So just because I can't imagine space working differently doesn't prove it can't.
Not in itself, no. Our past uniform experience is the real evidence, the source insists, but the strength of that evidence varies hugely depending on the scope and nature of the experience. Inconceivability is more about our psychology than objective reality.
This really highlights the tentative nature of a lot of what we think we know.
Especially the empirical laws we rely on daily. They're useful and valuable even, but potentially provisional, unless or until we can connect them deductively to more fundamental, widely verified laws. It encourages a certain humility about knowledge.
Okay, so we have these methods for reasoning for induction, deduction, but we inevitably make mistakes. The source dedicates a really helpful section to cataloging fallacies.
Yes, the common ways our reasoning goes wrong. Understanding these feels incredibly vital, especially today, for anyone trying to navigate arguments and information critically.
Absolutely. The source organizes these errors into categories.
Right. Broadly, fallacies of observation, mistakes in gathering the facts, fallacies of ratiocination, mistakes in the structure of deductive logic, fallacies of induction, mistakes in generalizing from facts, and fallacies of confusion, mistakes stemming from unclear language or muddled thinking.
Okay, let's break those down. Fallacies of observation.
These happen before you even start reasoning, really. Includes non-observation, simply missing important facts that are relevant to the conclusion. Overlooking counter-evidence, for instance.
Malobservation.
That's seeing something incorrectly or, more often, misinterpreting what you see. Confusing inference with observation. Thinking you saw something happen when you actually just inferred it.
Got it. Then fallacies of ratiocination.
These involve errors in the structure of deductive arguments themselves, like building an invalid syllogism, where the conclusion doesn't logically follow from the premises, even if the premises were true.
But the source says these aren't the most common errors in practice.
Interestingly, yeah. It suggests people tend to make these purely formal logic errors less often than they make mistakes earlier in the process, like having bad premises due to faulty observation or induction, or getting confused by language.
Which brings us to fallacies of induction, making bad generalizations.
Exactly. This is a huge area. It includes things like inferring a causal link based just on things happening together, correlation, without properly using methods like agreement or difference to rule out other factors. That's often called the post hoc ergo propter hoc fallacy, or what the source might term bad generalization a posteriori.
Jumping to causal conclusions too quickly.
Right. Another type is drawing broad conclusions based on only one aspect of a complex situation while ignoring other crucial interacting causes. The source calls this bad generalization a priori, or essentially relying on a false or incomplete theory.
And reasoning by analogy can lead us astray here, too.
Definitely. Analogy can be useful for suggesting hypotheses, but it's a weak form of argument for proof. Assuming that because things are similar in some known ways, they must also be similar in other unknown ways is risky. The source uses the example of assuming other planets must be inhabited just because Earth is. Based on analogy, it's suggestive, maybe, but not strong proof.
Okay, and the last big category, fallacies of confusion.
These often boil down to issues with language and the meaning of concepts. The source mentions things like the fallacia figurae dictionis, wrongly assuming that words derived from the same root, paronymous words, have exactly parallel or corresponding meanings.
Like assuming, presume, and presumption work exactly the same way logically.
Something like that, yeah. But even more common are simple ambiguities in words. Using the same word with different meanings in the same argument without realizing it.
Example.
The source points out using same sometimes to mean numerically one single object and other times to mean just indistinguishably alike. Or using a word like necessity sometimes to mean certainty, it won't necessarily happen, and other times to mean compulsion, it's forced to happen. Slipping between meanings can wreck an argument.
And it gives that really powerful historical example of how word meanings shift. Pagan.
Yes, how pagan, which originally just meant villager or country dweller from Latin pacanus, gradually shifted through casual association because rural areas were the last to convert to Christianity, to eventually mean heathen or unbeliever. The connotation completely changed based on association, not definition.
That's fascinating. It shows how easily confusion can creep in if we're not precise about what words connote.
Absolutely. And understanding this process, how casual associations can fundamentally alter the effective meaning of a word over time, is a vital defense against fallacies of confusion.
The source notes that scientific nomenclatures try to avoid this.
Exactly, by assigning fixed connotations based on specific, agreed-upon distinguishing characteristics, trying to prevent that kind of semantic drift and ambiguity.
Okay, this is a lot of ground covered on logic, proof, and error. Now, can we actually take these principles and methods defining concepts clearly, building propositions, using induction and deduction carefully, avoiding fallacies, and apply them to something as incredibly complex and, well, messy as human behavior and society?
That's the big question, isn't it? And the source definitely takes on that challenge. It argues, maybe controversially to some, that yes, human actions are ultimately subject to invariable laws, just like the rest of the natural world.
Even with free will, people often feel they make choices freely.
The source acknowledges the feeling of free will, but argues it doesn't negate underlying causality. The reason human action often seems unpredictable isn't because it's lawless, but because of the immense number and complexity of the causes acting on any individual at any time.
And there's a feedback loop, too.
Right. While our character is largely formed by circumstances, upbringing, environment, etc., our own desire to shape our character becomes another one of those influential circumstances, adding another layer of complexity.
So perfectly predicting exactly what one person will do next might be practically impossible due to this complexity.
Likely impossible, yeah. But the source maintains that the underlying laws governing human nature, how motivations lead to actions, how character develops, are still discoverable in principle, just like laws in physics or chemistry, even if the system is vastly more complex.
How does it propose we study this? It suggests two related scientific fields.
Yes. First, psychology, which it conceives as the experimental science aiming to discover the basic laws of mind, how thoughts, feelings, volitions, and actions follow one another, often influenced by our physical state, body-brain, finding the elementary laws of mental phenomena.
Okay, the basic building blocks. And the second field.
Ethology. This is described as the deductive science focused specifically on the formation of character. The source saw this field as largely yet to be created in its time, but its goal would be to take the fundamental laws discovered by psychology
And deduce from them how different kinds of character, virtuous, vicious, brave, timid, etc., are shaped or generated under various combinations of circumstances, education, social influences, etc.
Exactly. It's about understanding how environments and experiences sculpt personality based on underlying psychological laws.
And what about the most complex system of all society as a whole?
Society is presented as the ultimate challenge, the most complex case study. Social phenomena, trends, institutions, historical changes arise from the combined actions, thoughts, and feelings of countless individuals, each governed by those psychological and ethological laws.
So social laws derive from individual human nature laws.
Ultimately, yes. The source asserts that social sequences and coexistences result from and are consequences of the laws of individual human nature. However,
It's incredibly difficult to calculate.
incredibly, calculating the aggregate result of so many interacting causes simultaneously in a society is far more complex than even, say, predicting the path of a single planet interacting with just a few other bodies.
So the source is skeptical of overly simplistic approaches to social science, like trying to explain everything with one single factor.
Very skeptical. It criticizes what it calls geometrical methods in politics or social theory, which assume social phenomena result from just one or maybe two simple forces, like self-interest alone. It insists that social phenomena nearly always depend on a conjunction of many interacting causes.
So what's the path forward for understanding society then?
The source suggests that while a complete predictive science of society built entirely from first principles, a priori deduction from psychology, might be beyond our current capabilities, we can use history and observation to identify empirical laws of society.
Large-scale patterns we see repeating in history.
Exactly. Consistent tendencies, correlations between states of society, patterns of development. The ultimate aim of a general sociology, as the source envisions it, would be twofold. First, ascertain these broad empirical laws from the study of history, and second, connect them deductively back to the known laws of human nature.
Showing how those historical patterns naturally arise from the way humans think and behave.
Precisely. Linking the macro-level observations back to the micro-level foundations in psychology and ethology, verification through explanation.
And there's a really striking point the source makes about what drives social change, something about beliefs.
Yes, this is fascinating. It emphasizes the state of the speculative faculties of mankind, essentially. The prevailing beliefs people hold about themselves, the world, the supernatural, morality, possibility, as a hugely powerful, perhaps even the paramount factor, driving social progress or stagnation.
So how people think collectively is a primary engine of history.
That's strongly suggested. The source mentions approvingly Comte's idea of historical stages often being defined by the dominant mode of understanding, like theological, metaphysical, or positive scientific. Changes in fundamental understanding can reshape societies.
Does this downplay the role of individuals or governments?
Not entirely. It acknowledges the importance of eminent individuals and governments, but frames their influence carefully. They aren't seen as creating change out of thin air, but rather as being able to effectively steer or accelerate change when the broader circumstances, including those prevailing ideas and beliefs in society, are prepared or receptive to that influence. They work with the underlying currents.
Wow. This deep dive really has spanned the spectrum, hasn't it? I mean, from the absolute basics of what a thought even looks like when put into words.
A proposition.
Right, a proposition, all the way to trying to apply these rigorous logical methods to the, frankly, overwhelming complexity of human beings and societies.
It gives us such a robust framework, though, a
Hmm.
way of thinking about how knowledge is built, how truth claims should be tested.
It really highlights how foundational even seemingly simple concepts like naming and defining accurately are. If you don't get that right, clear thinking is almost impossible.
Absolutely. And the distinction between ratiocination, just applying what we already know, like running through a syllogism and induction,
Hmm.
the actual process of discovering new general truths from particulars, that's such a crucial insight into how science and learning really progress.
And spending time on fallacies. Gosh, understanding the common pitfalls in reasoning seems more relevant than ever.
hmm From misinterpreting words to jumping to causal conclusions to faulty generalizations.
It's a powerful reminder for all of us when we're processing news or arguments or anything to pause and critically assess how someone arrived at a conclusion, not just what the conclusion is.
Definitely. And while the source acknowledges the enormous challenges in applying strict logical methods perfectly to human character or complex social change,
It doesn't just throw up its hands.
no, it still provides a valuable perspective that there are underlying principles of causality at work, and that understanding the complexity, the interplay of multiple forces, is essential, even if perfect prediction remains elusive.
It certainly makes you think differently about the different levels of certainty we assign to things we know. Is this based on a direct, verified causal link, or is it more of an empirical pattern we've observed so far?
A pattern that might depend on a specific context we haven't fully mapped out yet.
Yeah, which perhaps leaves us with this thought to mull over. Given that navigating the complexities of human behavior and society seems to, well, resist simple, strictly deductive logic a lot of the time, what skills or approaches, perhaps building on the principles we've discussed today, like careful observation, awareness of fallacies, understanding multiple causation, are most crucial for you to make wise decisions and navigate that inherent uncertainty in these really important human domains?
That's a great question to leave people with. How do we apply this rigorous thinking to the messy parts of life?
Something powerful to consider as we wrap up this deep dive. We really hope this exploration has provided you with some valuable tools and insights for your own ongoing pursuit of truth.